In this video we are going to discuss the MATLAB program of the bisection method. So first let's see what is the program. What does this method says? So in this method, if the value of function fx is given to you and it is said that you have a root between the interval a and b, then we have to find the root of this function by using bisection method. So what are the steps we are using when we are doing it manually? So the very first thing that we have to do is whether the root lies between a and b or not. To do that, what we will do? We calculate the value of function at x is equal to a and the value of function at x is equal to b. Then if the value at a and the value at b are different in sign, then only we say that the root exists between the interval ab, else the root doesn't exist. For example, if f of a comes out to be a positive number and f of b comes out to be a negative number, or vice versa, if f of a is negative and f of b is positive, this implies that root lies between a and this interval ab. Okay, so when we are going to represent this in a program, we will use this. So what we can say, see here, the product of a and b, the values of function at a and function of b, is always less than 0 because it is positive times negative and negatives times positive. So we can say that f of a multiply f of b less than 0. So this thing is for the program. So we are going to use this technique. Okay. Now, what is next? So what next we have to do? Once root exists between this interval, then what we are using? Bisection method is a midpoint method. So what we will do? We will calculate the midpoint, which we generally denote by c. So midpoint by using a plus b over 2. Okay. Then the next step is to calculate the value of function at c. Now, depending upon the sign of the function at c, like if it is positive, it can be positive or it can be negative. So depending upon this sign, again we have to check these things like root lies between which interval. So what is happening here is, this was our initial interval a to b. Now we obtained a point c. Now we need to check if the root lies between this interval or in the interval c to b. So to do that process, again we have to check the sign of the function at c. Okay, so suppose if the sign of the function at c comes out to be positive, and let us suppose consider case 1. Okay, not case 2. In case 1, the value of function at a is positive, whereas the value of function at b is negative. So in this case, what will happen? If we are considering case 1, where f of a is positive, then in this case we say that root lies between the interval bc. Okay. Similarly, in the second case, if suppose f of a is negative, so the value of f of a is negative and the value of f of c is positive. So there is a change in sign. So remember, when f of a is negative, f of b is positive. So f of c and f of b is of same sign. So in this case, root lies between a and c. Okay. Similarly, if the value of the f of c is negative, we will say that for the first case, the root lies between ac, whereas for the second case, when f of a is negative, we say that root lies between b and c. So we have to make the program for this. So what is happening in this case? When root lies between B and C, then what we will see, A is replaced by A is replaced by C, not B. Okay, A is replaced by C, and then we have to go back here and repeat the process unless we reach to the required result. Now to do this in the program, what is done? So first of all, very first step is to get the function, to enter the function. So you can say that here syms x is written. So this statement declares x as a variable. As you can see that we are denoting the function as f of x. So here this statement will declare x is a variable. Okay, and MATLAB. Similarly, if you want to type the function in terms of y, you should be writing syms space y. Ensure that all the letters are lowercase because MATLAB is case sensitive. If you type here capital S, it will give you an error. Okay, then after that what we want the inputs. What are the inputs that is required? We need the value of the function, we need the value of A, B, as well as we need the tolerance level. Means up to how many decimal places we want the root to be equal. So we denote it by epsilon, and sometimes we can also use E to denote it. So let's see. This statement, you will enter the function fx in the second, and we enter the value. That value will get stored in the variable y. Okay, similarly the value of A gets stored in A, value of B gets stored in B, and to enter the tolerance we used here the notation E. Now what is the next step? Next step is what we have done here, calculate the value of the function at A and B. Okay, so for that let's do this step. FA is equal to EVAL. EVAL, it's a command which is for evaluate. It evaluate what? Evaluate the value of this function. So what is here? Here we are using two commands. Here we have the command subs. Subs means substitute. So what you have to substitute? First of all, where you have to substitute? You have to substitute in y. Y is nothing but your function. What you have to substitute? You have to substitute the value of x. Okay, and by what? By A, the lower point of the interval. Okay, so like you are calculating FA. So this is for calculating f of A. Similarly, this will give you the value of the function at B. Here x is replaced by B. Okay, then what is the next thing? Next thing is to check whether the sign is same or different. So we are going to check this one. So sign is either less than 0 or it can be greater than 0. So we can even use FA star FB greater than 0. If it is greater than 0, it means, what does it mean? Root naught lies between A and B. It means both are positive, isn't it? So third case that could be possible is both are positive. So it means root doesn't lie between A and B. And fourth case would be both are negative. Again, the root not lies between A and B. Okay, so that thing again we have to check. So this is what is done here. We started a loop, which is a condition if FA multiply FB is greater than 0. So it means root not lies between A and B. So we have to display, we have to give it as an output. So for displaying for output means this information should be getting outputted. So we use the command display command. Display given initial values, do not bracket the roots, means do not find the root. Okay, so if this condition is not true, it means root exists between a and b. So that's why we are using the next thing, else. If this is true, then this will happen. Otherwise, so for otherwise we use else. Else what will happen? We have to calculate the midpoint. So this is C. We are calculating the midpoint, which is nothing but a plus b over 2. And then what we have to do? We have to calculate the value of the function at this midpoint. So here we use for a and b, here we are using the c. So it is f of c, value of function at the midpoint. Midpoint. Okay. Then what we have to print? Suppose we want to get printed that what is our a, what is our b, what is our c, and what is the value of the function at c. This will give you the, when you get this printed, you can also check whether you have done any mistake or not. So it will give you the idea. Okay, so we are using slash n means new line, tab slash t for tab, to give us space between these two numbers a and b. Okay, we have tab button in keyboard as well, but for MATLAB we use backslash t. Okay, then this will get printed. Now after that we use node point I equal to 0. What is the purpose of this? Because we want to know that after how many iteration we got the root, like we calculated midpoint 7 times, 8 times, or how many times, so that we get the output. Okay, so for that purpose we set the node point to 0, I is equal to 0. Now we work with another loop, which is while loop. So what is the purpose of using while loop? We say that we keep on doing this process. If we go up, we keep on finding the value of c until we get two c values which are matching the level of tolerance. Like suppose first value, say c1, you got as 0.02, and the c2 value you get 0.023. Then if you need 2 level of decimal places accuracy, you will stop here. But if it is required 3 places of decimal accuracy, you have to still continue. Okay, you have to find c3. So that thing is done by using this loop. We write while the absolute value of the function at c is greater than epsilon. Fc is this, is the tolerance. F print, keep printed. Again we use this tab to print the values. Then when we use this, okay, so it means in first backslash t, a is getting printed, then b, c, and f of c. Okay, then if f of a multiply f of c less than 0, again we reached here now at this position, this one where we are checking the root lies between a and c or b or c. So program in a program we will do like this. If fa fc less than 0, okay, then change b to c. Means if fa and fc less than 0 means their sign is opposite. So what does it mean? Root lies between these two intervals, and then we need root to be replace b by c. Otherwise, if fa fc is greater than 0, it means root not lies between a and c, root lies between b and c. So we replace a by c. So we are just replacing the midpoint. Okay, so this is if loop, which is getting end over here. This thing process keeps on continuing. Then once this process is done, we calculate second midpoint. Now see here, the formula is still c, still b, but you note that either a or b is replaced by c. Okay, then we calculate the value of fc as evaluate substitute y x c, and then we increase I to I plus 1 because we completed one iteration. Okay, and then we put n. So it means this is the while loop and this is the ending of this while loop. So this process keep on continuing unless this condition is satisfied. Unless this condition is satisfied. Okay, this condition. Then once this condition is satisfied, it means we get the root as per the required order of accuracy. So it will be displayed. So we are displaying I, the number of iteration it took, as well as the root. Okay. Now let's see this in the MATLAB.